Thank you. And thank you for coming to From Evidence to Practice, the Science of Math Paradigm. This is part one in a five-part series, and this is where we will delve deeply into, in these five parts, how children learn math and how there is a real direct corollary to the science of reading research around how children learn reading, and what we can take from that to inform increasing math achievement for students. So, like I said, this is part one of a five-part series. And in part one, we're going to be introducing the framework that draws upon all of the research around science of reading and how we can provide a similar framework for elementary teachers in math. And in order to do so, we really need to look at what happened, what has been happening in research around how children learn, and why we are hearing so much about science of reading. So, in this 30 minutes, we are going to cover the history and background of research and movements to teach reading and math in the United States, and where there are overlaps and where there is ways that we can draw on what we've learned from reading. And then we're going to introduce a framework for how I believe we can change the narrative around math. We can push math achievement and accelerate learning if we can help teachers understand how kids learn how to learn math. What are all those building blocks? And then we're going to just briefly talk about the next steps, what you're going to get in the next 4 sessions of this webinar. So, I will be sharing my background throughout the webinar, so I'm not going to give a lot here, except to say that I'm a former middle school math teacher, and I left teaching math to get my PhD to study how kids learn math, because so many students were coming to middle school not prepared for middle school math. Where I was teaching, which was in a suburban school district, I would say about 80% of students coming into middle school were not prepared for middle school math, and I could not understand why. So I went back to the University of Pennsylvania. I got my PhD in studying how children learn math. My dissertation was an exploration of the numerical reasoning of middle school students. And I interviewed students and asked them task-based problems and asked them how they were thinking. And it fundamentally changed the way I think about how we teach. It led me on this path to figure out, how do we fix this problem? So you'll be learning more throughout the series about my background, but that's it in brief. And finally, we named this specifically. We were intentional about naming our series toward a science of math paradigm, because in the last few years, everywhere in the education space, you hear science of reading, science of reading, science of reading. And I wanted to share a little bit of background on how we got there for those who don't know that background. So, uh, so in the 1990s, in the United States, there was an explosion of reading recovery and a way to teach reading that was based on Marie Clay, a New Zealand researcher who was working with students who were having trouble learning how to read. And she developed a method. The primary piece of it is called the cueing method, that rejected phonics instruction and introduced a more whole language approach to learning how to read. And so this method is called the cueing method, and that students would learn how to read by using context clues and cues in the other words that they know. But by the 2010s, there was a lot of kind of alarms going off, but also a lot of research around how kids actually learn how to read, brain research, neuroscience around how children learn how to read. But the thing that kind of tipped it over the edge was the pandemic, because in during the pandemic, when children began learning from home, parents started seeing how their children were learning how to read. And they started saying, wait a minute, that's not how I learned how to read. And my children aren't learning how to read. My children aren't getting better. And it raised alarm bells. But the thing that kind of was, I think, the nail in the coffin for reading recovery was a podcast called Sold to Story that came out in 2022. And if you have any opportunity to listen to this podcast, you should. It reads like a novel. It presents itself like a novel. It is so good. It's in several parts, but it really lays out how we got here, and then the science of how we fix it. And because of that, then what started was institutions that had embraced this reading recovery started to distance themselves. So, Columbia Teachers College got rid of Lucy Calkins' Reading Institute, completely disbanded it, ended it. Fountas and Pinnell are some other big reading recovery people who were part of this movement who now have moved aside, but also publishers who were using reading recovery resources. Heinemann is the number one, really took a major hit because of this rejection of reading recovery. And then there were legal challenges. So there are parents who have sued states for the way their children failed to learn how to read. And so there's a big drawback. So the question is there a corollary in math? And there is, but I want to share there's a fundamental difference between the reading wars and how we ended up with a framework and the math wars and how this is a much harder conversation. So uh, those of you who are old enough may remember that in 1983, so the math war started actually in the 60s with Sputnik and the race to the moon. And the new math was introduced. And then there was a lot of kickback on that. And in 1983, this major work was published called A Nation at Risk. And the most famous quote, this was quoted as all over, and it scared, legislatures all over the country, said if an unfriendly foreign power had attempted to impose on America the mediocre educational performance that exists today, we might well have viewed it as an act of war. As it stands, we have allowed this to happen to ourselves. So that kind of kicked off a new, we need to figure this math thing out. And so in 1989, the National Council of Teachers of Mathematics introduced their first kind of standards document. And that went from 1989 to later in the 90s, which introduced ways that students should learn math. And one of the most controversial things is that they didn't need to learn their math facts because calculators were becoming ubiquitous. And so students would be able to use calculators. And so we didn't need to do this. But by 1999, there was a call to action. People were alarmed at the curriculum that was coming out as a result of the NCTM principles and guidelines for math. One of the ways that students it was thought that students learned is this constructivist approach to learning, meaning that students construct their own knowledge. It's all within them, and we just need to open up and facilitate that learning for them. So there wasn't a lot of very explicit, direct instruction, and there was just giving students opportunities to explore and develop their own understanding. But by 1999, there was an open letter from mathematicians and scientists that said, this isn't working. This isn't working. We're going in the wrong direction. And that laid the seeds for a document called the Common Core Standards for Mathematics. And so by 2010, Common Core standards were published. And this was intended to be Common Core, that across all 50 states, we agree that these are the standards that students need to be able to learn math. But very quickly, the Common Core standards were rejected, and state by state, states started creating their own standards. The two states that initially had like the biggest visceral response is California. California kicked off a math war based on the Common Core standards and said we need our own standards. And Texas also um, really rejected Common Core standards and created their own. So the thing is, students are not learning math in the same way that they were not learning reading. But why don't we see a revolution like what happened in science of reading? And I have three reasons why I think we're not going to see this revolution. We're not going to see a very clear framework for how kids learn how learn math in the same way that we have it for reading. And that's because one, there are not enough researchers doing research in math education. You have 10 times the amount, by orders of magnitude larger, of people who do research in reading and how children acquire reading than they do in math. So the research is just not out there. But the second thing is that in the pandemic, when parents saw students, their children learning how to read, they were able to say, wait a minute, this isn't this I know how to read, and my child is not learning how to read, and there is something wrong with that. But children were not learning math in the same way. But parents' responses to children not learning math were, for the most part, eh, I never learned math either. This tracks. I had a hard time in math, and I'm doing fine. So the level of urgency around math is not there in the same way that it was for reading. And the final reason why I don't think we are going to see a revolution like what happened with science of reading is that administrators don't value this in the same way that they value reading. I was at a conference last spring where there was a panel of 16 superintendents, and those 16 superintendents each went around and shared what their focus was for their district. And all 16 said their focus is reading, their focus is reading, their focus is literacy. And they all have the same talking points. If children don't learn how to read by third grade, then they're lost, right? But the same is true for math. If we don't give students the foundation for building math in by third grade, then much is lost. So I got up and said, we know that the top 15 paying college majors, the top 15 paying college majors all require strong math understanding. So why aren't we also focusing on math? That it's not an either or, it's a both and. But until administrators acknowledge or accept or embrace the fact that math is this needs the same amount of focus, the same amount of intention that we're putting into reading, then we're not going to see a revolution that happens. But why do we need a framework? I mean, we have the standards and everyone says, oh, does this meet the standards? Are you meeting the standards? We have the standards, but why do we need a framework? So when I completed my dissertation, when I completed graduate school, I decided that I didn't want to go into academia. I decided that I wanted to start a consulting business working with middle schools and high schools and help them get kids on track to be successful in middle and high school math. And when I did this, and I would travel all around the country, I would do an exercise with middle school and high school teachers, math teachers, and I would have them just help me list all of the skills, everything that students should learn by the time they leave elementary school. And in a group, we would just put it all up on the board. We put it on the whiteboard on chart paper, and we would list everything. And it could be anything from being able to convert measurements, to being able to tell time on an analog clock, to knowing the algorithms, to number sense, there was just, a lot of skills. And by the end, we would have 30, 40, 50 discrete math skills that middle school and high school teachers expect students should walk out of fifth grade knowing. Like fifth grade, you should have this mastered. So once we did that, I would then ask these teachers to, as a group, come up with the top three. And I would say, if elementary schools could only teach three things, if students came out of elementary school only mastering three things, what three things would they be? And so these teachers would come together, come up with three things, and then I would say, okay, let's look at my slide. Let's see if those three things match what's on my slide. And I have done this exercise with middle school teachers and high school teachers all over the country many, 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 many times. And every time, what they come up with, their top three, is my top three, is shown on the slide. So I'm going to share with you what those top three are. So the top three skills, this is if you are an elementary teacher, if you're an elementary school administrator, these are the only skills that middle school and high school teachers care about. Not that they're not the only ones that they care about, they're the most important. They're like, if nothing else, if you do this, we can take these kids and they can fly. So the number one skill is automaticity. Basic fact recall. That's the number one skill, it always is. The number two skill is a deep and flexible understanding of fractions. Now let's say that in order for kids to have a deep and flexible understanding of fractions, they must have automaticity, because teaching kids understanding least common multiple, greatest common factor, a common denominator, all of those things that they need, they have to have automaticity. And so by fourth and fifth grade, when the focus is on fractions, decimals, students need to come into those classes already with this foundation. Just like in reading, where we say, kids from K to 3, kids learn to read. From fourth and on, they read to learn. It's similar to math. From kindergarten to third grade, we need to build this foundation for being able to do math. And a deep and flexible understanding of fractions is the second one. And the final one is they want kids to have reasoning, a particular kind of reasoning, and that is, does my answer make sense? Does my answer make sense? If I put something into my calculator and it returns an answer, am I able to say that doesn't make sense? That's off by orders of magnitude. That should be, the decimal's in the wrong place. They want that. But in order to have that skill, you need automaticity. So the funny thing is, I started then working with elementary schools and elementary teachers and did the exact same exercise. I do the exact same exercise with elementary teachers. I said, let's list all of the skills that students should know by the time they leave fifth grade. What do you think they are? And then come up with the top 3. And I have done this many times in elementary schools, and never, not once, has the top 3 matched my slide. So there is a real mismatch in schools around what elementary schools are teaching and what middle schools and high schools expect. And we need to get on the same page about that. And a framework can help us at that. So let me go. So what is a science of math framework? So for many years, when I was working with older students and I would interview them, I continue to interview kids on tape. And when you look at the rest of my series, I will be sharing a lot of video of students talking about math. But I would interview them and I would start listing all of the things that kids needed. And then how do we get them there? What are the parts that make up the whole? And it's different than what is it that students need to know and be able to do. This is, what are the things that put students in a place where they can learn? What are those building blocks for learning? And so I came up with a framework that is aligned with Science of Reading framework, and this framework is called CRAFT. It's the key to understanding student math acquisition, okay? And I want to share with you how that aligns with Science of Reading framework. Okay, so counting, we're going to do our next series is all about counting, and this is the most critical skill a student should learn in order to build a foundation for understanding and learning math. It is so key that we have built it into everything that we do. Now, counting correlates with phonemic awareness and phonics in our Science of Reading framework. So in Science of Reading, the students need to understand that letters have sounds, and then you could put letters together to make blends and phonemes. There are phonemes that you put together, and those are put together to make words. And that is the same with counting. There are ways that you can count, and you count forward and backwards by different ways. And your ability to count also lays the foundation for your ability to do addition, subtraction, multiplication, and division, your understanding patterns, your ability to recognize similarities and differences. It's all built on this foundation of counting. So reasoning is the same as comprehension in the Science of Reading framework. Automaticity is like sight word recognition, or another word called orthographic mapping. Orthographic mapping is the quick ability to use the rules of language to quickly know what a word is, to be able to say a word. So there's orthographic mapping, and sight word recognition are being able to know words on sight that don't match any of the rules that are part of orthographic mapping. So those two things make up that part of Science of Reading, and they align with automaticity. See it, know it, see it, know it. So there's see it, know it, and then fluency is the same as fluency in Science of Reading, but fluency is see it, know it, do something with it. So there's things you have to be able to In reading, you have to be able to quickly know what these words are. But fluency is put those words all together in a string and understand what the paragraph says. And that's similar with math, that there is see it, know it, and then there's do something with it. And then tenacity is something that we've developed in our part because we believe. And I have worked with students at all different levels, and I say this all the time. For students who are struggling and students who are advanced, the problem is the same in math. We do not give challenging enough problems to them for students who are struggling and students who are advanced and all the students in the middle. So we created another thing called tenacity, and we want students to be able to stick with, focus, and stick with hard things. So what do the standards say about the components of the framework? I looked at Common Core standards in two states, the Common Core standards in two states, California and Texas. One, because they're very large, two, because they've had these really big math awards. And I want to share, what does this say about these 5 areas? And here's where we end up. With counting, how is counting treated in the current curriculum standards? Now, our first session, October 1, is about counting, and I want you to come to this session because you will see how critical counting is. But this is how it is shared in the Common Core standards. After grade 2, counting fades from the standards, from the Texas standards, from the California, and from the Common Core standards. It's not an explicit skill, so it's not like these are the standards, these are the ways that students should be able to count. We believe that by the time a student leaves elementary school, they should be able to count to any number, from any number, by any number. And they don't require counting backwards. So automaticity and fluency. So we know, how is automaticity? That is the number one thing that middle school and high school teachers want us to be able to do. And I'm going to show these just very quickly. In the Common Core standards, they talk about knowing from memory all sums of 2 one-digit numbers, and by 3rd grade, knowing by memory all products of two one-digit numbers. They do not mention subtraction. They do not mention division. Texas is full automaticity for all of them, and California doesn't even mention automaticity. They just say procedural skill and fluency. Now, in 1997, Texas did have the word automaticity in their California had the word automaticity in their standards, but they took it out. And so I'm just keeping track of time because I want to leave time for questions. Fluency, the same thing. We're seeing that these top things that middle school and high school teachers want, there is not a real strong place for them in the standards. Our final ones are reasoning and tenacity. And we want to say the only way students can develop a mathematical reasoning is if they have a robust and flexible use of language. If they have a strong vocabulary and an understanding of the notations associated with mathematics. And we want to be able to say a student is reasoning, but they may be reasoning at a different level. So this is how the reasoning is treated in the Common Core standards in Texas and California. One thing I have to say, when I go into classrooms and kids are engaged in math talk, I could be in a 4th grade classroom and they're explaining their thinking, and I'm like, yeah, but that's at a 1st grade level. So we want to give teachers a real map for what it means to reason when you're in 4th grade around math. So I'm looking at the time. We keep this to exactly 30 minutes. The next 4 sessions are going to take each one of those parts of the framework and delve very deeply into what that means for you. But